Okay, so today we're in section 6.5, Similarity and Measurement. In a lot of ways, it is similar to what you learned yesterday in section 6.4 about similar and congruent figures. Most importantly, probably, what you can carry over from yesterday's lesson is setting up proportions. You're going to see a lot of that in today's lesson where we just set up proportions given just relationship between different numbers. And basically this first slide is just talking about that. Similarity and measurement. And basically how you can use similar triangles and similar figures to actually find the measurements of the other sides of the figure. Okay, you don't have to write anything down from this slide. All right, so starting off with example 1, we're going to use these two figures to find side EH. Now, you do have to kind of figure out, okay, how is this? I've got my slanted side here on top. So where is my slanted side in the bottom figure? CD. So you know that that figure is kind of laying on its side. Does that make sense? So what is the corresponding side to GH? No, GH. DC or CD. Okay. Now, the proportion that I set up has to include the side that I don't know. All right? And you have to make sure that for each ratio you're comparing either the first shape to the second shape or the second to the first. And here's what I mean by that. Let's start off with, in the first shape, the side that we know, GF. Okay? GF. What is the corresponding side to GF? No. What is the C what? CB. CB. I thought you said CD. Okay, so it's going to be CB or BC. So here's what I did. I went first figure to second figure, right? So in my second ratio, I have to go first figure, which I need to include the side that I don't know. So EH over, what's its corresponding side? EH to AD. All right, now I can fill in my numbers. The length for GF is 30. The length for BC is 12. The length for EH is X, I don't know. And AD is 16. And now what do you think you can do? Cross products, you can do algebra. I would not do equivalent ratios, but you're just solving the proportion. So go ahead and solve the proportion. All right, so I have 480 equals 12x. Divide both sides by 12, and x equals 40 inches. All right, so now I want to do the same thing. Okay, I want to find the unknown side length, except now this is a triangle. Now imagine that triangle DEF is just flipped, so flip it directly vertically. So now F is at the peak, D is in the bottom left, E is in the bottom right. All right, so set up your corresponding sides, your ratios, make a proportion, and then solve. Can we draw the shape? Yes, there is a typo. You're solving for side DE. That's why the X is over here, in between D and E. Okay? All right, so now set up your proportion. All right, so we're going to do SU over ED equals TU over EF. All right, now we're going to plug in our values. That's going to be 35 over X equals 45 over 36. Cross products, 45x equals what? What's 35 times 36? 1,260. Divide both sides by 45. X equals 28 what? Millimeters. You got it right. Okay, good. All right, now in example 2, we're using what we call indirect measurement. Indirect measurement is when you use similar figures to find the lengths that are difficult to measure directly. That's called indirect measurement. So let's look at this cactus example. Okay? All right, yeah, I know it's kind of a funny picture. All right, but guys, pay attention. So we're going to find the height of the cactus. Okay, the height of the cactus. Now, there's several ways that you can set up this proportion. You could do the corresponding sides, so height over cactus over the height of the man, and the length of the shadow over the length of the man's shadow. You could also do height of the cactus over length of its shadow, and height of the man over the length of the man's shadow. Do you see that? Okay, there's several ways that you can set up the proportion. Sticking with basically what we've been doing so far, we're going to use our corresponding sides. So height of the cactus over height of the man equals the length of the shadow of the cactus over the length of the shadow of the man. All right, so now we're going to use cross products to solve. Okay, so 2h equals 30. Divide both sides by 2, and the height of the cactus is 15 feet. Okay, see what we did?
Yes, ma'am.
All right. All right, any other questions? Anything? Okay, I want you to try one. All right, let's do the checkpoint. It says the cactus is 5 feet tall and casts a shadow that is 1.5 feet long. How tall is a nearby cactus that casts a shadow that is 8 feet long? Set up a proportion and solve. Okay, so there's a couple ways. I'm going to do the two common ways. If they did height of the first cactus over height of the second cactus equals shadow of the first cactus over shadow of the second cactus. Or you could have done height over shadow equals height over shadow. Which one did y'all do? Did y'all do one of those?
I did the first one.
The first one or the second one? Okay. All right, now either way, you're still going to get the same answer. So you have 1.5x equals 40. Divide both sides by 1.5. And you do get an odd number. It's going to be 26.6 repeating. Now we do know that that's going to be 26 2/3. All right, and we know that 2/3 of a foot is 8 inches. So we could say 26 feet, 8 inches. Now, on your homework, your quiz, and your test, that's going to come out a lot more evenly. Okay, but that's just, that's basically how we would find that answer. All right, moving on to example 3, the last example. Using algebra and similar triangles. Now, here's what I want you to see from the start. You have one large triangle, triangle A, B, C. You see that? Okay, that's one triangle. Then you have a triangle inside the triangle, and that's going to be triangle DEC. So you have a smaller triangle within a larger triangle. Do you see that? Yeah. All right, so now we need to set up a proportion using corresponding sides, and we need to solve for the side that we don't know. So here's how we would do it. We start with the larger triangle, triangle ABC. Okay, what is the height? What side is the height? Side what? AB. Side AB. And what side is the base of the big triangle? BC. B all the way to C. Okay? B all the way to C. All right, now what is the corresponding side to side AB? DE. DE. What is the corresponding side or the base of the small triangle? It would be EC. Okay? EC. Now let's fill in the values for these sides. Side AB is what? 20 inches. And DE is 15, so 20 over 15. Now what about side BC? BC is going to be X plus 36. It's both of those that combine together to give me the entire side length. So I'm going to say x plus 36 over, and then EC is just 36. Do you see why we did that? X plus 36? Because the whole side BC, right here, this whole side is 36 plus x. It's both of those measures. All right, so now I'm going to do my cross products to solve. 20 times 36 is what? 720. Okay, now I have 15 times x plus 36. I need to do a little distributive property here. 720 equals 15x. What's 36 times 15?
540.
All right. Now what do I do to solve?
You subtract 540.
Subtract 540 from both sides. Starting to run out of room. Okay, and then 720 minus 540 is what?
180.
180 equals 15x, and how do I solve for x? Very good. Divide both sides by 15. 180 equals 15x. Divide both sides by 15. X equals 12 inches. And that's how I would solve. Okay, let's see. Is there a checkpoint for that? I don't think. All right, so if you understand that, that is everything you need to know for 6.5.